Chris Penn. Chris Penn is a
You're not going to be the whole thing, are you?
Well, you're a very important person.
No, God, that's like forever. Let's get started.
All right, Chris Penn.
Thank you. All right, good morning, everyone. If you would like to follow along, you can get the slides at the aptly named wherecanigettheslides.com. So if you'd like to get that, you can do that right now. Let's get started. Marketing is in an interesting place right now. Everyone wants better, faster, and cheaper. How are we doing as marketers at better, faster, and cheaper? Let's look at better. In the 2019 PricewaterhouseCoopers Library something or other survey of CEOs earlier this year, when CEOs were asked, what are the critical things that you think are important? 94% said data about your customers and clients' preferences and need. 92% said data about your brand and reputation. 85% said benchmarking data on the performance of your industry peers. CEOs said this is vital, critical information. And yet, when they were asked, are you getting it? 20%, 23%, 20%, 17%. So on the one hand, the CEO suite is saying, this is exactly what we want, but you're not giving it to us. We have such integration problems. In the most recent CMO survey, which came out last week, if you go to cmosurvey.org, you can get it, we see that there's an ever sort of flatline, declining ability to get information across channels. Customers are saying, we don't know where to find anything. You heard it some of the keynotes. We're doing all this content marketing. It's not even saying the same thing. When asked, CMOs said marketing analytics contributes more to company performance than social media and mobile. Right? So we clearly know data is important, and then yet when we asked how many companies use analytics and data for decision making, a underwhelming 39% said we do. The other 61%, I'm guessing, are guessing, which is just a terrible idea. So we're not getting better, but we're getting faster, right? At least we're getting faster. Well, maybe. In this year, calendar year 2019, we will create, as a civilization, 40 zettabytes of data. Now, a zettabyte is unimaginably large. Some of you are like, I don't even know what a zettabyte is. If you started binge watching Netflix and didn't stop to eat, sleep, or use the restroom 55 million years ago, you just began to 1 zettabyte now. And we're going to create 40 of these this year. That's how much data there is. In just 60 seconds on the internet, just from year to year, there are huge differences, right? In 2018, we watched 266,000 hours of Netflix a minute, person hours. In this year, 694,000 hours. That is a tremendous increase in the amount of Netflix and chill. Twice as much scrolling on Instagram, same amount of text messages, 300,000 more Tinder swipes this year alone. Mostly right, I'm guessing, by the increase in Netflix. Younger crowd this time, more people left. So there's a lot of variety. Even in the news itself, traditional news stories, we are on track for 100 million news stories this year. To give you a sense, if you were on the front page of the New York Times or the Wall Street Journal, you and 178 other news stories would be happening that minute. That's how much news there is. So you'd be gone like that. So we're not getting faster. Marketing isn't getting faster. Marketing might be getting a little bit faster, but the world is getting much faster, so we're falling behind. But at least things are cheaper now, right? Things are cheaper, things are better. No. Marketing spend, highest in 5 years. Marketing budget as a percentage of firm budget, highest in survey history. We are spending more than ever. And yet, when you go back to the CEO survey and say, what are your top priorities and concerns for revenue in the year to come? All of them, 77% said operational efficiencies, which is code for budget cuts, right? So we're spending more than ever, and CEOs are saying, stop spending so much. What happens? Right? So one of the answers to this quandary of the fact that we're not better, we're not faster, and we're not cheaper is artificial intelligence, which is simply about us using tools that improve speed, acceleration, accuracy, and automation, right? Making things go faster. Machines are way faster than we are. Doing things better at certain tasks, machines are just so much better than we are. And taking care of the repetitive, boring stuff. How many of you have at least one task a week that you do that you hate doing? It's boring, right? If you haven't raised your hand, I'd like to know where you work. Machines can help us do all of these. Now, What is this stuff? Because there is a lot of talk about it. The joke for the folks who are in the profession is that if it's code, it's machine learning. If it's on someone's PowerPoint, it's AI, because everyone seems to be using the term. But we'll unpack this. Intelligence is a series of routines, right? Humans go through these routines. If you can hear the sound of my voice and it's not noise, you're using what's called language processing. If you can see me and differentiate me from this lovely background, you're using vision. And we're trying to teach machines to do these things with things like algorithms, machine learning, and deep learning. So let's unpack these terms as to what they mean. All AI begins with statistics and probability. AI is math, not magic. Right? There are no unicorns, no pixies, no fairy dust. It's just good old math. If you were cooking waffles, stats and probability and your data would be the raw ingredients, right? Simple, plain stuff. That's where it all starts. Next, with those techniques, we build algorithms. These are repeatable processes with a known outcome. You use algorithms all the time in marketing. If you've done A/B tests, you've used algorithms. If you've done SEO, you use algorithms. You use algorithms every day in your own life. I guarantee you, the price of a pastry, retail value $5 or less, because some people put like weird gold on their donuts, that you probably put the same general article of clothing on first each day. Right? Some people put the top on first, some people put the bottom on first, a few weirdos put their socks on first, but you do the same thing, right? Those are algorithms. In the cooking example, this is a recipe, right? A recipe is an algorithm. Now, where things change from the video game on your laptop or on your phone to all the software you use today is in machine learning. Instead of humans writing the software, just like instead of a human cooking the waffles, we're teaching machines to make the waffles. And we do this with two branches of machine learning called supervised and unsupervised learning. Supervised learning is nothing more than trying to get a machine to recognize patterns so that it can replicate them. So I would show a machine 1,000,000 pancakes. Here's 1,000,000 pancakes. This is a pancake. This is a pancake. This is a pancake. A whole bunch of this is not a pancake. Until we could get the machine to reliably recreate a pancake. Right? That's supervised learning, trying to get a machine to find a known outcome. The most famous example of this is IBM Watson's oncology division. In 2013, at the University of Tokyo, they were trying to treat a woman who had leukemia. They were trying to treat her, and she wasn't responding. She was getting worse. They took her genome and sequenced it, fed it to Watson. Then they took 233,000 oncology journals, fed that to Watson, and said, figure it out. What are we doing wrong? Known outcome. Watson looked at all of it and said, you're treating the wrong kind of leukemia. You've misdiagnosed it. So they changed the treatment. She made a full recovery. That was really cool. That's supervised learning. And oh, by the way, Watson did it in 11 minutes. That's supervised learning. Unsupervised learning is when we have a whole bunch of data and we're trying to make sense of this, right? So here's a whole bunch of food. What kinds of foods are there? And then we can ask, are any of them pancakes? I don't think so. I don't think I was grilling pancakes that day. That's taking a whole bunch of data and trying to make sense of it. Example from recently, I was running late for a client meeting, poor planning on my part, and I needed to summarize 2,600 articles that were written about this client into a brief that I could say to the client, hey, here's what happened. So using a technique called topic modeling, we digested them, the machine digested them down into this one chart of what those articles were broadly about, and I was able to do that in 5 minutes, make it to the meeting, and get a cup of coffee. That's unsupervised learning, the ability to organize data. From there on, there are these techniques called deep learning, which is just connecting all this stuff together. And what the net result of deep learning is machines that are better, faster, and cheaper than we are as humans. Now, all of this architecture, all of this understanding is not so that you learn how to code. You don't have to. By the way, does anyone actually write code? No? Not this time? Okay. Not so that you learn how to code, but so that you learn how the lingo. Why? Because when you go down to the expo floor, every vendor is going to say they have AI. And you need a finely tuned sense of what our Spanish friends would call detection of excremento de toro to know who is telling the truth. Last year, the Financial Times did an assessment of companies that said they used AI and found 35% were lying, zero AI in them. Right? So you need to know the terminology so that when you talk to the salesperson at the booth, you can say, okay, cool, you say you have AI, what kind? Tell me a bit more about the architecture. That's when the salesperson gets really panicked and looks for an engineer. If they have an engineer, they know what they're doing. If they don't have an engineer, they're just trying to sell you something. But you need to know this. The state of the art, where the technology is today, is being able to group and cluster AI together, like a group of people working together. In February of this year, IBM held an event called Project Debater. They had an AI, which was actually a bundle of 10 of them, on stage with a human debate champion. And they said, no prep, 15 minutes before we're going to tell you the topic. The topic is, should we subsidize kindergarten? Both contestants had to figure this out. It was funny, IBM put a big plastic box with lights on stage. There's nothing in the box that just had to blink a lot because you can't visualize an AI. The machine and the human prepared their arguments, they delivered their opening statements, they rebutted each other's arguments, and then they did closing statements all in real time. That's where the machines are now, the ability to do this type of complex interaction, listening and interacting. That's the state of the art. That said, there still are a substantial number of limitations. Machines today cannot do empathy. We define empathy as knowing what someone's going through and acting on it. A machine can analyze, but it can't take that next step, that next action. You can see that somebody's upset, but literally the machine cannot hug them, right? Machines cannot perform human judgment. You ever been to a restaurant and you greet the server pleasantly and they give you an extra appetizer? You're the first customer today has not treated me like trash, so have an extra appetizer. That is human judgment. Machines cannot do that because they literally are the rules, so they cannot go outside the rules. The third thing is machines are very bad at cross-domain things. AI is really good at narrow tasks. It can't do things across domains. So your life experience, what makes you human, machines have a very hard time with. And the same is true of domain expertise. If you are one of the best in the world, for example, in industrial oil pumps, you have knowledge that is so deep and minute that there's not enough to train the machines on. So your domain expertise is really important. And finally, for the most part, people want to deal with people. Machines are not as good at relationships. The exception is, for those of you who are not American, we have this organization in America. It's called the Department of Motor Vehicles. Nobody wants to deal with them. Their customer experience is so miserable, you would much rather deal with a machine. So if your customer experience sucks, then yes, you'll want to use AI for that because mediocre machine is much better than antagonistic human. So how are we using this stuff in practice? Heard the theory, got the general idea. What is this stuff? The top uses, according to the CMO survey, are things like content personalization, predictive analytics, targeting decisions, customer segmentation. Those are fine, broad descriptions, but let's look at what the actual implementations of some of these look like. See if any of these problems sound familiar. Number one, you don't know what's working and what's not in your marketing, right? Number two, you don't know what content should be priority. Number three, you have no idea what's valuable in your data. Number four, you can't predict or plan for what's ahead, so you're always scrambling at the last minute to try and crank out today's blog post. And number five, you have no idea who can help you with your reach. Does anyone have any of these problems in their content marketing? Is anyone who has none of these problems? No? Okay. We have one person who raised their hand, you can go. So what are the AI applications of these things? So the first one, you don't know what's working. There's a mathematical technique in machine learning called Markov chain modeling, when you build code around this, and it's like digital Jenga. Imagine every time somebody visits your website from Facebook or a webinar or email, these are individual blocks, right? And sometimes there's a conversion and sometimes there's not. And if you pull the block out and the tower falls over, then you know that block was really important to that conversion. Other times you'll pull a block out and nothing happens. Right? When you do this with the data that's already in Google Analytics, you have to get it out, and then you have to run it through machine learning software. You get a digital customer journey map that tells you what order those blocks are in, whether email is beginning at the end, and then the likelihood that the tower is going to fall over, and how important that block is. So in this case, this is my company's data. Organic search is our number one channel for impact. Right? If I pull that block out, 26.9% of the time, my tower is going to fall over. So I'm not touching that. It's staying in there, right? On the other hand, Instagram is barely visible. So I'm going to kick the Instagram blocker right out of my tower and nothing will ever happen, right? This helps us understand what to prioritize. And it helps us understand our messaging. Down here, you see Twitter is towards the end of the customer journey. Now, if my messaging is, hey, get to know us, you know us already apparently, because that is closer to conversion than it is to awareness. So I should change my messaging on Twitter to be more like, hey, get this white paper, download these slides. As opposed to LinkedIn, which is way up there at the top. If I'm saying buy now, buy now, buy now, and people are like, who the hell are you? My messaging is mismatched. So customer journey mapping using machine learning is a very effective way to figure out what's working. Second application of this, anytime you have numerical data that has a known outcome, you can use machine learning to figure out what makes that work. So like what's the secret ingredient in the recipe? I wanted to look at one account's Instagram growth. Do not take this as gospel. This is only one account. It does not apply to you. I said, what causes follower growth on this account? Using a technique in machine learning called gradient boosting. We looked at all the data we have available about Instagram posts, and it said the addressable engagement rate was the best predictor of growth. So if I could get more engagement on this account, I could get its follower count to grow, because we were told to make the followers grow. Stupid metric. Number 2, you don't know what content's priority. Using the exact same technique of Markov chain modeling, blocks. There's an apocryphal story from years ago about a college that never put sidewalks down. Right? They built this new campus, they didn't put sidewalks down, and then they let students wander around for a year, and then they just paved over where the holes in the lawn were as the sidewalks. Right? That's where people wanted to walk. When people are walking across your website, there are certain pages that will encourage them to convert. And so using Markov chain modeling, the same type of machine learning, you can figure out what are those pages that people, when they walk across that page, are more likely to convert. Once you know that, then you put it into action. You put it in your email newsletter. You feature it in your social posts. You run ads against it. At the bottom of your blog post, you say, you might also enjoy these posts that have nothing to do with what you're reading, but we know they're going to make it convert. Right? So that's this technique and how you use it today to increase your conversion rate optimization. Another example of this is with SEO. SEO is filled with this. All these SEO tools are great. They offer tons of data, but it's very hard to make sense to see how data relates to each other. Like you've got all these metrics. What's important? Using a technique called clustering, you can figure out what numbers go together. In this case, I wanted to look at the search difficulty, the search volume, and the search rankings clustered together, and what pages for this insurance company they were most vulnerable at, right? They had good volume, they were getting searches, but their rankings was terrible. We need to fix this page as soon as possible to lock in and make that page more difficult for their competitors to rank for. So using clustering for that. And then we use that exact same technique on all their competitors. We figure out what terms do their competitors rank for that they get volume for, but they have there's low keyword difficulty. Let's go and make a whole bunch of content and steal their market share away from them. Right? So being able to use these mathematical techniques in machine learning to know how to beat competitors. Very, very valuable. Number 3, you don't know what's valuable in your data. There's a lot of it. As of yesterday, so far we've written 151,000 words collectively about content marketing world. 3 novels. Right? That's it. Anyone had time at this conference to read a novel? Right? Much less 3 of them. That's how much content we're creating. And yes, there are very simple tools like word clouds that can tell you like what the most frequently used words are, but that's not helpful. That doesn't boil up the things that are relevant. But using a technique called text mining or topic modeling, we can find out what words are important based on their position in a document. Imagine a page of text as a map, right? And you know that there's a big word like, New York City. What are the towns around New York? You know there's a big word like content marketing. What are the words that are around it so that you can better understand what's being said? So in this case, things like you need an editorial director for your newsletters. You need to create quality content. Yeah, we know that. Long-term loyalty. Lee Odin's content marketing is in there. Content marketing efforts, content marketing strategy. Being able to digest down what's being said. When International Women's Day happened this past year, I and my CEO, Katie Robert, were like, what should we do about this? Should we attempt to participate in a meaningful way? So we ran this analysis. There were 1.6 million posts by noon that day. We ran this analysis, looked at the model and said, we have nothing to offer to this conversation. There's no reason to jump in. Let's just sit on our hands and let it go by so that we don't embarrass ourselves and offend a whole bunch of people, right? But by being able to do that, you can know, yes, jump in, or no, shut up and, and just let people do their thing. Another example, we were doing some work for a truck driving company that was recruiting. They said, our applications are down, we don't know why. So we looked at 5,000 of their Indeed.com job ads, and these were the words that were the most prominent in their ads. They were hitting people in the face. You need to be this age, you need to have this class of license, you need to be comfortable with this kind of truck. Then we took 17,000 calls from their call center, transcribed them, and ran them through the same assessment. Look what the drivers were talking about. Pay in cents per mile, starting cents per mile, home on the weekend, training, truck driver type, process, signing bonus. So on the one hand, you have the company saying, this is what we demand of you. And on the other hand, you have, this is what the drivers are interested in. They're not even at the same restaurant, much less dining at the same table. Of course your applications are down because you're not saying anything the candidates want to hear about, right? So we advise them, fix this. Now think about your own content marketing. When was the last time you pulled all of your social media data, all of your blog data, everything that you were saying, and then look at your audience, what they were saying, what the industry was saying, what news articles were saying, and compare the two? Are you talking about the things that people want to hear about? If you do this analysis, you can figure out very quickly, yep, we are, or no, we're not. No wonder why no one likes us. Number 4, prediction. You can't predict or plan for what's ahead. Using techniques called time series forecasting, you can take any word or phrase and use back data from services like Google Trends or the SEO tool of your choice and forecast forward week by week when someone is going to most likely search for that term. So this week, content marketing template is going to be the most searched term out of all these different content marketing terms. So if you have a blog post about a content marketing template, this would be the week to promote that. In the first week of November, what is content strategy is going to be the most popular search term that week. Guess what? If you don't have a blog post, if you were a content marketing company, and you didn't have a blog post called What is Content Strategy, you would be missing the boat on what people cared about when they cared about it. That's the value of time series forecasting. It is not just what's important, it is when it is important. Imagine the search terms for your industry, annuity, insurance, life insurance, term insurance, and stuff, and when those terms would be searched for, you would time your content with that. You would time your ads with that. You would calibrate your ad budget with that. Why spend money during periods of time when nobody cares? Right? Spend money when people care. We do a version of this where we look for the term Outlook out of office. Because what are you about to do when you type that into Google? You're about to go on vacation. You're trying to find out, how do I turn them on my out of office? And so there are certain weeks when that term is super high. Guess what? We don't send email that week. We don't run ads that week. Why bother? Nobody's home. We actually do send an email newsletter. The subject is the worst performing email of the year. And the 5 people who read it usually reply back and say, that was really funny, I'm stuck in the office. And you can boil this down into a simple template that you can give to someone on your staff saying, this is what we're doing this week for promotion. This is what we're planning for next week for publication. This is what we're prepping this week for 3 weeks out. This is what we're planning 4 weeks out. So that kind of forecasting lets you stop panicking about content and be on time with what your customers care about. 5th example, you don't know who you can help you reach. A lot of what is called influencer marketing today is really who's got the biggest mouth, right? It is not super helpful unless you are a brand that's marketing things like a Kardashian. What's more useful is who is most talked about, right? So as of late last night, I looked at every tweet about Content Marketing World and whose handles were referenced most. Not who did the most talking, but who got the respect of the audience. So right there's Lee Oden. Lee, congratulations. Well done. By doing this type of influence analysis, then turning it into a nice little spreadsheet, you know who to talk to about getting your stuff featured within their expertise. These are the people that the crowd is looking up to. And so you can analyze that, not just with tweets at a conference. You can do this with academic journals. You can do this with news articles. Anywhere where there's a defined entity that you can track, you can see who is most talked about. And that gives you insights about who to pitch for public relations. It gives you who to reach out to if you're doing influencer marketing. It can even help you do recruiting, right? If you're trying to find new talent. I was talking to somebody yesterday at one of the events, and they said, yeah, we're trying to figure out who to highlight as up-and-coming speakers. This is a great way to do it because not all these people are speakers, but they are people that other people reference. So those are the 5 problems that you can solve with machine learning today. It's in production and available today in the market. It is not futuristic navel-gazing. Answering why are we doing some things, where are things working, what data do we have, when should we do things, who should we be talking to. Those are the 5 applications. You need to start now because remember, machine learning is software written by machines based on data. The sooner you start, the sooner you're collecting data, the sooner you can start building models. So how do you get started? It's a 7-step process. The first step in this process, this journey to AI, is finding, cleaning, preparing your data. This is where almost everyone gets stuck. Like 90 to 95% of the companies we've worked with get stuck here. He got hired by a company last year because of regulatory requirements and silos, they hired us to get their data about their company from third parties to give back to them because they couldn't get their own data. And like, I mean, sure, we'll do it, but it was just madness. This is where most AI breaks down. You don't know where your data is, and so on and so forth. Your second step in the journey is to become a data-driven company where you make decisions with data first. And this is not a technology problem. This is a people problem. If you walk into more than 5 meetings a week where you hear the term, this is the way we've always done it, I strongly recommend you update your LinkedIn profile because that company is going out of business, right? Being able to work towards KPIs. If you're going to use machine learning, you need to have something for the machines to target, right? A KPI is super easy. If it's a number that will get you fired or a bonus, it's a KPI. Everything else is a metric. The third step in the process is to become research-driven, to be able to have qualitative capabilities. No AI at all today can dig into somebody's head and say, why did you attend this session? Why did you buy that purse? Why did you abandon that shopping cart? You don't know unless you ask people, why did you do these things? And you need that data because you can then build models based on those findings. And the fourth step is automating your processes internally, trying to find as many optimizations to free up time because AI is a profession unto itself. It's expensive, the people expenses, and when you deploy it, it is time and resource intensive. You need time in your own schedule. How many of you do content curation for social media? Quick show of hands. Okay, how many of you spend at least 2 hours a week on it? How about 4 hours a week? Anyone spend 8 hours a week on it? Okay, good. I got tired of doing that. It's boring. So I wrote software, not machine learning, just plain old-fashioned regular software to pull in 1,500 blogs, tag them for topics I cared about, and score them, which got clicked most, which got shared most, and then the machine spits out the top 50 each week. Now I don't have to do content curation. It takes 4 minutes to do social for the week for the company. That is 4 hours that I now have to spend on machine learning and AI for my company. So find those processes in your company that just suck up time and they offer very little value, but you know you have to do them or your boss told you how to do them, and automate them away. Now at this point in the journey, there's 2 forks in the road. If you're going to be applying artificial intelligence to your core competency, the next 3 steps you must do. If, on the other hand, you just want your marketing to be better, the next 3 steps your vendors need to do, and these are questions to ask your vendors. The 5th step is, what data science capabilities do you have? Data science is detective work. Remember that machine learning is software. You're building software. All the machines are building software. They need to know what to build, right? So data scientists help solve the mysteries in your data to understand, hey, this is the problem that's worth solving, or this is the problem that you can solve, and then build software to solve that problem. So that 5th capability is really important. And data scientists are weird creatures. They're a blend of coder, statistician, and business strategist. Yet they're kind of all 3 mashed into one. So you need that to know what software to build when you get to machine learning. As you start rolling out machine learning, you'll be solving specific tactical problems. How do we make our SEO faster? How do we improve our social engagement? How do we do this? And then rolling out models, which is a fancy way of saying software, to solve those problems. At the end of the journey, you are using AI to solve problems first. It is your default go-to. There are not many companies like this. There's like 10 of them on the planet, and you know 5 of them: Facebook, Amazon, Microsoft, Google, IBM, right? Everyone else is not there yet. This journey, by the way, if you're starting here, is about a 10-year trip, right? Because of culture, because of resources and things like that. So just keep that in mind. Should you buy or build comes down to a very simple set of decisions. If you have time and you don't have money, you're building it. If you have money and you don't have time, you're buying it. But again, most important, if your core competency is the thing that you're going to apply AI to, you must build it. You do not want your secret sauce in the hands of a vendor. That is a terrible position to be in. So make sure that as you're thinking about your strategy, you decide which branch you're going to go. If you're going to buy it, there are tons of great applications out there that already solve very specific point problems. Folks over at MarketMuse have a great content curation service. If you got in here and you heard the music in the last few minutes before we started, that was all machine-composed music. It wasn't great, but it was inoffensive, and it filled the silence. There's a service I use called Otter. It transcribes audio. Every call I'm on, I have Otter transcribe with permission, so that I can go back and review what I said, because some days I have no idea what I said. Google Analytics is starting to roll this out. There's a button in the upper right-hand corner called Insights. When you push that button, Google says, hey, these are the weird things I noticed about your data. You might want to look at it. There's even sort of an Ask Google box there that you can start asking these applications questions. So AI will find its way into your favorite applications eventually. If you're going to build it, the preferred solution right now in market is IBM's Watson Studio, because there's pieces and chunks for every level of skill, from like drag and drop stuff to, hey, if you just want to write code, you can. If you have access to developers, the 2 languages that are most important are R, statistical language, and Python. These are languages that are worth learning if you are inclined to do so. If you are not a programmer and you've never tried it, and you have no interest, then you'll have developers that program in these languages. How do you get your company ready for AI? You're going to need 3 kinds of people. There's a 2006 professor at Duke said data is the new oil. Fantastic expression, because crude oil is sticky, nasty, disgusting stuff that does nothing and stains everything it touches. You need to do stuff with it to make it useful. Same is true with AI. You need developers to get at the data wherever it lives in your company, extract that data. This is Steve Ballmer screaming and sweating profusely at a Microsoft concert. You need data scientists to take that raw data and refine it, transform it. By the way, if anyone's curious about how to measure social media influence, this is it. No? Okay. It's called inference adoption probability. And then you need marketing technologists to take those insights and put them into action. Remember earlier when we were saying you have the best pages on your website. That's cool. What do you do with it? Oh, you need a marketing technologist to fix that widget on your blog, to run those ads, and so on and so forth. So those are the 3 kinds of people you need: developers, data scientists, and marketing technologists. If you're a big company, you do it in this order, right? If you're a small company, so big company, Fortune 1000 and above. If you're a smaller company, you do it in reverse order, because marketing technologists should be able to provide enough easy wins with or without machine learning to increase revenue to then afford the other roles. This is the most expensive role. A data scientist with 4 years of experience in Silicon Valley will cost you no less than $500,000 a year. Right? They are super, super, super expensive talent. So to the extent that you can find additional revenue first to pay for that, or outsource. How do you prepare your career? This is the question everybody has. Here's the good news. The Brookings Institute said this really well. AI will take away tasks, not jobs. Instead of playing first violin, you will be the conductor of the orchestra. So the job you're in will not go away, it will change. Now that said, there will be fewer people needed to do that because it will change. There's only one conductor of the orchestra. Right? But the machines will do stuff, and then we as humans will train them, and we as humans will quality check them. So how do you increase the likelihood how do you increase your value? First, you need to become multidisciplinary. When you look at the top skills that LinkedIn analyzed this year, every single one of these skills has a bunch of tasks that can be automated. There are some jobs that, yes, are one task. I used to work at a PR firm, and there's this one poor person. Their job was to copy and paste things from Google into a spreadsheet every day, 8 hours a day. I'm like, for all of our sake, I hope that job gets automated, because you will have no soul by the time you leave this job. But if you are good at sales leadership, and you are good at video production, and you are good at people management, you are very hard to replace, because your knowledge crosses domains, and you can put together things in ways that machines cannot do and will not do for some time. Second, you need to become an algorithmic thinker. That doesn't mean learn how to code, but it means learn how to think like a machine. Every time you look at a problem, you should be thinking, is this a problem that I just need to solve, or is this a problem I need to build a system to solve to make it go away forever? If there's a problem that shows up every month, you absolutely should figure out a system to solve it and make it go away forever. That's algorithmic thinking. When you learn how to think like that, suddenly you start thinking, how can I use a machine to solve part of that problem? The third thing you'll need to do is machine oversight, to watch what the machines do and to quality check them. This is a huge area. This was its own career. In 2016, ProPublica did an expose on a police department in Florida that attempted to predict recidivism using machine learning. Recidivism means your likelihood to commit another crime. The algorithm was 20% right. Now, you'd have been better off flipping a coin. But it flagged African Americans as 5 times more likely to reoffend than they actually did. There was bias in the data. Really, really bad. And that machine was making literally life or death decisions for some people, right? Another example from last year, Amazon tried to build an AI tool for resumes, and it stopped hiring women. Well, no crap, guys. If you've only hired developers, men 95% of the time, then when you build an algorithm, of course it's going to say, yep, just hire men. So we have to oversee the fairness of these machines and make sure that the output is fair. And there are technologies coming into the market now that can help us do that, can say, yep, this is your protected class. Like gender must always be 50-50, even at the expense of a less efficient model, to guarantee those fairness things. We also need to, and you also need to have ethics in mind. This is an example of a deep fake. Jordan Peele, the comedian, is speaking, and they mapped his impersonation of former President Obama onto President Obama's face. President Obama never said these words. He's doing a comedy routine. This is a case where, if you remember the famous quote from the movie Jurassic Park, Dr. Ian Malcolm said, "Your scientists were so concerned with whether they could that they never stopped to think about whether they should." So a major part of AI in the next 5 years is going to be about ethics. What is ethical? What is allowed? What is not allowed? And you have to be outcome focused, which means you don't have to necessarily worry about learning how to code. This is a chart I used to have hanging up in my cubicle. And I was trying to learn this framework, Keras, which is a deep learning framework. And I got to the bottom of the first column in like 9 months, and I was like, ugh, it was so difficult to learn. Then I went to IBM's Think Show in 2017. They said, why are you doing that? We have a drag and drop interface. Just drag and drop it. I'm like, oh, shit. There goes 9 months I'm not getting back. I went to Think again this year, and they said, oh, well, that's last year's history. Now you just drop the data set in, and the machine does the whole thing, and then you just assess the output and decide whether it's relevant or not. So you don't have to be a coder, because the machines are learning how to code themselves. You just have to know what outcome you want. Your job is to be the chief questions officer. Is this fair? Is this expected? Is this intended? Is this aligned with our strategy? I'm going to end with where things are going. Machines are creative. They can create now at levels never seen before. I took a whole bunch of tweet chats, questions from tweet chats, and I fed them to a system called GPT-2 by the OpenAI Institute. And I said, write me some new questions. And what it came up with was not bad, right? Does having limited visibility on social media affect your work environment? That was not in the training file. Is having to manually fill out surveys especially bothersome when you can opt out whenever you want? If you could do one thing about pandering to just one demographic, what would it be? Not bad for a machine writing. And by the way, it wrote 20,000 of these, right? With the push of a button. So machines can write. I'm not an artist. This is one of my drawings. It's good, isn't it? But with a tool called Gauguin from NVIDIA, it can take this and render it as a photorealistic painting. I am not an artist. So one of the things to think about is, yes, some jobs will have some tasks consolidate down. But then this opens up a whole realm of possibility. Have you ever heard the expression, I know you've got a book in you, right? I know that I wish I could compose a symphony. I wish I could paint. Our limits as humans will be defined only by our ambitions because the machines will help us with the talents. So that's something very inspirational to look forward to. If you have something you've always wanted to do, but you don't have the talent for it, now you have help. Now the only limit to what you can do and accomplish in your lifetime is going to be your ambition, your desire to do it, because the machines can help. So, thank you very much. I look forward to seeing what you create.
Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.